The noble gases are unusual in that they exist on their own as single atoms. This is to do with their stable electronic configurations. Helium has a full outer shell of 2 electrons, and the other noble gases have 8 electrons in their outer shells. Other elements try to achieve the same electronic configurations as the noble gases by chemical bonding. When elements achieve 8 electrons in their outer shell through bonding, we say they have obeyed the octet rule. Covalent bonding generally occurs between non-metallic elements and involves atoms sharing pairs of electrons. This sharing can be shown with a dot and cross diagram. For example, when 2 chlorine atoms combine to form a chlorine molecule, the 2 atoms achieve an octet by sharing a pair of electrons. In dot and cross diagrams, you need only draw the outer shell. We can simplify covalent bonding by drawing a single line to represent a shared pair of electrons. Water can be represented like this, or as dot and cross diagram like this. Similarly, ammonia, NH3, can be represented like this, or as a dot and cross diagram. The ammonium ion, NH4+, contains a special type of covalent bonding known as a dative covalent bond. This is where 2 electrons that form the bond are donated from one atom, in this case the nitrogen. We draw the short form as this, where the dative covalent bond is shown with an arrow. Carbon dioxide contains 2 carbon to oxygen double bonds, which are represented in short form like this, and as dot and cross diagrams like this. Ionic bonds tend to occur between metals and nonmetals. An ionic bond is defined as an electrostatic attraction between oppositely charged ions. Ionic bonding involves transfer of electrons. In sodium chloride, the single outer electron of sodium is transferred to chlorine. Both sodium and chlorine end up with an octet in their outer shell. The sodium, because it has lost an electron, has a single positive charge, and the chlorine, because it has gained an electron, has ended up with a single negative charge. We need only show the empty outer shell of the metal ion when drawing dot and cross diagrams. Calcium has 2 electrons in the outer shell, and so to obtain the octet would need to lose both of these to form a 2+ ion. Oxygen needs to gain 2 electrons to obtain its octet. The third type of chemical bonding is metallic bonding. Metallic bonding is the electrostatic attraction between positive metal ions and delocalized electrons. With sodium, the single electron in the outer shell is delocalized, meaning it is not attached to any single atom, but is free to move, and this creates a strong electrostatic bond between the singly positively charged sodium ions and the delocalized electrons. Magnesium, being a group 2 element, has 2 electrons in the outer shell, and these 2 electrons are delocalized, which leaves a metallic ion with a 2+ charge. The increased charge of the metal ion and the greater number of delocalized electrons makes for a stronger metallic bond than sodium, and consequently explains why magnesium has a higher melting point than sodium. The delocalized electrons in metals account for why metals conduct electricity, since these delocalized electrons are free to move and carry the charge.